Hey, today we're going to talk about volume of pyramids and cones. What I want you to do is on page 339 of your student journal, you get a couple minutes. I want you to do your best to answer those three questions. Okay, here we go. Okay, what's the formula? Yeah. Good. The volume is equal to the base times the height, which gives you the volume of your entire prism, right? And since it takes three of these, we'd only need 1/3 of the entire amount. Okay? Very good. So one pyramid fills up 1/3. 1/3 base times height, or base times height divided by 3. Okay, so relating it to what we know from previous lesson there. So using that information, I want you to take a look at the next page. Unless they've changed it in your student journal, you need to note that this is a regular hexagonal prism. Okay? So it's a regular hexagonal prism. All right, go ahead and work on question number 2. Guys, when you're calculating this, remember, a good strategy for those of you struggling, think of your base, drop an altitude, which we call the apothem. Okay? Think about how many degrees are in each of those triangles right there. That'll help you out to find the needed information to find the area of that base. You're going to use that formula, A equals 1/3 BH. So find the area of that base. They give you the height. You need to find B to be able to find the area. Okay, remember this angle right here is 30 degrees. Okay, we know that because 360 in the entire thing divided by 6 sides would give us, we had the rest of the triangle there, so this triangle, that would be a total of 60 degrees. So 30 plus 30 is 60. That makes that 1, which makes this length right here, if you think of a 30, 60, 90 triangle, if you're using special right triangles, if x equals 1, this side is x root 2, which is 1 root 2. So your apothem here is 1 root 2. So the area of the base is going to be 1/3. Remember, this is the formula for area of the base is 1/2 AP, all times 3. So that's 1/3 times 1/2 of root 2. And then the perimeter is 2 times 6, or 12. Okay, so we end up with, multiplying all that together, we get 6 root 3, which is approximately 10.4 cubic inches. Yeah, 100. Root 2 is this length right here. Using special right triangles, x, 2x, x root 2. Okay? Good question. Maddie? You could have, yeah. You wouldn't have got the root form, but you would have got the rounded form. Okay. Yeah. What's that? Yeah, I take them off sometimes. Okay. It's very comfortable up here. Take my shoes off. Actually, I've got my throwing socks on right now. Volume is equal to 1/3 base times height. Okay, that's how we find the volume of cone. All right. Or volume of a pyramid. When we get to volumes of the cone, I want you guys to read number 4 there and answer that question real quick. Okay. Okay. So, what do you guys think? Yeah. Yeah, it's going to be the same formula, right? 1/3 base times height. What actually changes there? Cynthia? Good. The base is now pi r squared. It's a circular base, right? So when we get to that, you'll be ready for that one there. Okay? Just circular base here. Okay. I want you to go ahead and turn the page. There's a little summary in terms of the core concepts, and you can go through and do some vocab later if you need to, okay, to help review. But let's take a look at page 342. You're going to complete problem number 1, number 3, number 5, to begin with on that page, okay? Those problems. And this one right here, number 1, I think is a little confusing in the way that they draw it. This is a point back here, and that actually has a side dropping to that vertex back there, okay? So that is your pyramid, if you can see it three-dimensionally. I hope that helps. Yes? Oh, you guys have them? Mine just isn't cool enough. How did I do? Oh, you guys actually have all these lines. That's good. Mine doesn't. You guys are so much cooler than me. Some of your all right, I'm going to draw all mine in so I feel as cool as you.
Pretty much.
Okay, 1, 3, and 5. Off you go. Hey, let's check our work there. It's on the first one. We've got 36 cubic centimeters. You're doing 1/3 the base times the height. So the base, you have 1/2 6 times 4. Okay? And then all times the height of the pyramid. So make sure you don't confuse the height of your base and the height of your actual pyramid. Number 3, 1/3 area of the base times the height. It's a little easier on that one because the base is a square. Any questions on 1 or 3? Number 5. They give you the area of the base. That one makes it a lot easier. Okay. I know. I don't know why they do that. Okay, any questions on those? Okay, let's try a couple others. I want you to turn to page 343. I want you to try number 7 with your groupies there. Make sure you read it carefully. Draw a picture if needed to help you out. If not, just write out the formula. Hey, the papers I saw walking around, many of you doing this. Quite a few of you actually had the numbers plugged in. Some of you that were struggling, I think the disconnect will come right here where you're going, well, I need to find the area of the base, and you can actually find B, but it asks for the side length. Okay, so your first step would be to find the base, because base, the area of a base, if the base is square, that means the way we find the area is multiply side by side, or side squared. Okay, so if I take 1/3 of 6, I get 2, so I have 2b is equal to 128. B is equal to 64 then. And then if I know that b is 64, I can plug that in there. And to find the side length, it's just the square root of 64, which is 8, or 8 inches. Okay? Drew. You don't take 1/3 of 128. If you're going to deal with this 1/3, you have to multiply by 3 to undo it. Yeah. I just multiplied these two together to get the 2, and then divided by that. Other questions there? Huh? Yeah, let's go. All right. Hey, why don't you take a look at number 10. Pyramids are similar. Find the volume of pyramid B. This would be cool. Remember, if they're similar, you're taking your similarity ratio, which is your linear ratio, so 15 to 10. I'm going to reduce it to 3/2. Okay, that would be comparing A to B. However, if you're trying to find the volume of the other one, you got to go A cubed to B cubed. Meaning you've got to cube each of these. So raise it to the third power. So 3 cubed is 27, 2 cubed is 8, so that's your volume ratio, similarity ratio. And then you can say, I know that one, I know the bigger one, so I put it with the 27 because that's the bigger number, and I need to find the smaller. This is my question mark, so we'll call that B, and that gives me 27B is equal to 8 times 125, which is 1,000. So B is 37.04 cubic inches. All right. How many got it? Well done. Any questions?